Hey guys, happy Wednesday. So today we're just going to jump right into it. So I hope by this time you guys kind of understand the drill, right? If you have your notebook, make sure you guys are taking notes inside of your notebook. If you still do not have one, you can still follow along using the Go formative. So let's just go ahead and jump into it. So take a minute, guys. Try this warm up. If you've already done it, go ahead and hit play, and then I'll go through the solution here. All right, guys. So here's our second essential from semester one. It's calculate rates of change. In other words, your slope. Now, there's different ways you could have done this. There's different ways you could have done this. Remember, rate of change slope. We use the letter M to represent that, and it's delta y over delta x. It's the change in the y over the change in your x's. So for the first one here, it says find the rate of change for section A. So if I take a look at section A, it's from this point all the way up to this point here. Well, you could have done it two ways. The first way you could have done it is by counting, by actually looking at the graph and counting the change in your y's over the change in your x's. So if I take a look at this one, well, let's see how much the y's change by. To get from this first starting point to the second one, how much do you have to go up or down? That's the change in your y's. Are you going up or down on this elevator? Well, let's count how much we're changing in the y direction. We're going up 20, 40, 60, 80. There was a change from 0 all the way to 80. So we went up 80 steps there, 80 units. So right now I have my rate of change looking like this. M is equal to the y's change by a rate of 80 over, we want to do the same thing now, but we're going to do it on the x-axis, right? We're going to try to figure out how much do those x's change by. So now we want to kind of count from left to right. So now be careful on this one. On the y-axis, we were counting by 20s, 20, 40, 60, 80. When you're counting left and right here, the x-axis, they're just counting by ones. All right, so this is going to be 1, 2. So just two spaces. The x's here are changing at a rate of 2. Now, that is technically our rate of change, 80 over 2, but we can do better than that. M here is equal to, what's 80 divided by 20? That is just 40. The rate of change for section A is 40, or 40 over 1. Every time that you go up, let's see if I can highlight this. Let me erase a couple things here. Every time you go up 40 steps, you scoot over to the right 1. And if you keep that pattern going, right, up another 40, and to the right 1, we see that, hey, we land on that same line. There's our rate of change. There is our slope. The other way that you could have done it is by using a table of values. So remember, we can use a table of values. And you could have grabbed these 2 points. This first one down here is 0, 0. So I'll put 0, 0 first. And then for the next point way up here, that is sitting at 2, 80. 280. And again, if we find the change in the y's, those were changing at a rate of positive 80. The x's were changing at a rate of positive 2. We get still that same fraction, 80 over 2, which simplified to 40. So you had options there. It was completely up to you. All right, let's move on to the next section, section C. So let me try to highlight that one from from this point here all the way up. This is representing section C. And again, what I prefer to do whenever I have a graph, I think it's a lot nicer to just count it. Just go ahead and count your slope, count that rate of change. Well, let me find the change in the y's first. Let me go ahead and find the change in the y's. M is equal to, well, to get from this first point to that top point, I'm going to go up 20, 40. All right, be careful. We're counting by 20s on the y-axis. So even though I did climb up 2 boxes, 2 steps there, we are counting by 20s. I went from 80 to 100, from 100 to 20. Now, how do I count on my x's, right? We're trying to find the rate of change in our x's. Well, that's going to be just to the right 1. So that is going to be 40 over 1, or simply just 40. All right, and again, that's saying every time you scoot up 40 spaces, you're going to scoot over to the right 1. All right, we got one more section here to take care of, section E. Where's section E? All right, so from section E, it starts way up there. Let me use a different color that pops. Whoops, wrong thing. Here, let's use that yellow. So from way up there, section E, all the way down until we crash onto the x-axis, right? And notice your line is going down. If you kind of read it from left to right, you're going down. So I should be getting a negative slope, a negative rate of change. These other ones, they were climbing up. They were climbing up from left to right. That's why we got positive 40s. So let's see what happens here. So let's find the change in the y's first. Again, let's find the change in the y's. How do I go from this top point way up there to this bottom one? Well, I have to go down 20, 40, 60, 80, 100, 120. I have dropped down 120 spaces. And because I counted down, that is going to be negative 120. That is going to be negative 120 because we were going down, right? Not up. Now, what about the changes in our x? Well, to get to that point over there, we scoot over 1, 2 spaces to the right. And again, on the x-axis, we're counting by 1, so that's just simply 2. Yeah, that's our slope right there. M equals negative 120 over 2. Or if we actually simplify it, it's negative 60. Every time you scoot down 60 spaces, you would go to the right one. I can actually show you guys that right now. If you count down 20, 40, 60, and then you go to the right one, notice you end up on that same line. If you count down another 20, 40, 60, and then to the right one, you still end up on that same line. There's that constant rate of change for that section at least. All right, so there is rate of change, guys. There's your warm-up. Today, we're going to keep practicing, guys, those two little shortcuts, those two properties of exponents, which we called product of powers and then power to a power. So this is day 2, just getting that extra practice. At this point, it really just does take practice. Practice makes that perfect. So product of powers and then power to a power. These we'll focus on a little bit later on this week. So let's just jump right into it. Now, what do you recall? For these here, guys, what I want to do is I actually want to simplify these. I actually want to multiply these out, and then we'll get into practicing those properties. So don't forget, right? This is something you should have learned back in middle school. 2 to the 5th power, 2 to the 5th power. That's the way that you read that. And it's not saying 2 times 5. That is what we call an exponent. It's a little number that sits up in the top right corner. And this 2 over here is what we call your base. What does the exponent tell us? That tells you how many copies of that base we have, and we're going to multiply it. So here I have 5 copies of that 2, and we're going to multiply those all together. 2 times 2 times 2 times 2 times 2, 5 times. That's the expanded form. If I asked you guys to expand that out, this is what you would have to do. Now we can actually multiply it because these are nice whole numbers. 2 times 2 is 4. 4 times 1 more 2 is 8. 8 times 2, 1 more 2 is 16. 16 times 1 more 2 would give us 32. If you actually went through and multiplied that out, you would end up with 32. We could do the same thing with the second one here. 3 to the 4th power. What does that mean? It means you have 4 copies of the 3 that are getting multiplied together. So 3 times 3 times 3 times 3. And if we actually simplify, we actually multiply that out. 3 times 3 is 9. 9 times 1 more 3 is 27. 27 times 1 more 3 would give us 81. So all I did was I went through and multiplied it. And again, these are nice whole numbers. If those were variables, I wouldn't be able to do that. All right, let's keep it going. So, I kind of already talked about the vocab, but again, guys, don't forget exponents. It's that little number that sits up in the top right corner, for example, here, the 4, and it tells you how many copies you'll be multiplying. It's also referred to as the power. You'll hear me use the word power, not really exponent. What about the base? Well, the base is the bottom number here that sits in the bottom. That's the one that's getting multiplied repeatedly over and over and over and over, right? And please be careful, guys. One more time, you never multiply a base times an exponent. No. That's not the way it works. That's not the way it works. So be careful. I sometimes get students doing that. So product of powers. Yesterday we should have found out the pattern. In case we weren't here or forgot it, what is product of powers? It's when you multiply 2 terms with the same base, we add those exponents. Product, remember, product is just a fancy way to say multiply. Whenever you are multiplying, right? So take a look at this example here, very generic example. If you're ever multiplying and you have the same base, a and a, what can I do with those 2 exponents? Whatever those numbers are up there, we're simply going to add them together. Let me give you guys a couple of examples. Let's say you have a to the, whoa, that is not an a. Let's say we have a to the 3rd times a to the 4th. Well, I realize here that I am multiplying times. I have the same base, a and a. So what do I do with those exponents? I can go ahead and add those together. 3 plus 4 gives us 7. This would be a to the 7th power if I wanted to simplify. Now, why do we want to learn this this product of powers, this property, this shortcut, if you will? The reason you want to memorize it is because this is what you would have to do. If we did not know this product of powers, this shortcut, what you would have had to do here is you would have had to expand this a to the third power means you have a times a times a 3 times. And then you're multiplying that by a to the fourth. Well, how many more a's are we going to multiply here? 4 more. So 1, 2, 3, 4. For a total of 1, 2, 3, 4, 5, 6, 7. So that's why we write that as a to the 7. Right? But nobody wants to expand. Nobody wants to do that work. That's exhausting, right? And again, imagine if I gave you something ridiculous. Let me exaggerate it here. Let me say I gave you guys something like x to the 100th power times x to the 300th power. Nobody's going to sit here and expand x times x times x times x 100 times and then do another 300 x's after that. We know that, hey, product of powers, if you are ever multiplying, we are multiplying these x's together, and they are the same base, x and x. What can I do with those exponents? We're simply going to add them. So what is 100 plus 300? That gives us 400. This would be x to the 400th power. Okay, that's how we simplify that expression there. All right, let's get into a couple more examples here. So what I want you guys to do, if you're watching this video on your own, pause the video here, guys. Try these out, try these out, try these out. Yeah, some of these towards the end kind of get a little funky, but again, it does not hurt to try out, right? Look, put what you're thinking on paper, and then if we're wrong, it's completely okay. Well, that's how we learn. That's how we learn. All right, so again, take a minute, pause it here. When you're ready, go ahead and hit play. All right, so for the first one here, x to the 4th times x to the 7th. I realize that, hey, I am multiplying. I have the same base as x and x. So what's the shortcut say? What's that property, product of powers say? We're going to go ahead and add 4 plus 7, which gives us 11, right? And again, could you have expanded this out? Could you guys have done x times x times x times x 4 times and then multiply that by another 7 x's? 1, 2, 3, 4, 5, 6, 7. Yes, you could have, but that is exhausting. You have 11 x's. It's just much nicer to use those properties, x to the 11th power. All right, for the next one here, you have x to the 8th power times x to the, what is there? Where there's, I don't see an exponent. Well, if we don't see an exponent, guys, there is a 1 there. That is x to the first power. It's kind of tacky to write it on there, but I'll do it just so you guys can actually visually see it. So again, just like before, if we're multiplying, we have the same base. We can go ahead and add those exponents. 8 plus 1 more is going to give us 9. This is now x to the 9th power. All right, the next one here, h to the 3rd times h to the 2nd. This is still multiplication. Whenever you see two sets of parentheses next to each other like that and there's no plus or minus in between, you are multiplying. So this is saying h to the 3rd times h to the 2nd. It's just a different way to write it, and it works just like the first two problems here. So if I use product of powers, since we are multiplying, I can just go ahead and add those exponents. 3 plus 2 gives me 5. H to the 5th power. H to the 5th power. All right. The next one over here. Now we start adding a couple more variables, right? Not just dealing with one, right? Not just dealing with x's or h's. Now you're dealing with c's and d's. Well, think of this as two smaller problems put together. If you get overwhelmed, if you're getting overwhelmed, don't look at the entire thing. Cover a couple of these things up. Let's work with the C, since this the letter C comes up first. Imagine this was not here. Let me cover it up for a minute. Cover it up. Imagine that was never there. And then let me cover up the other D here. I just want to make sure that I keep whatever has that same base. If you're looking at that right now, to me, that says c to the 7th times c to the 5th. That looks just like problem 1, problem 2, problem 3. Product, we're multiplying. Same bases, c and c. What can I do with those exponents? I'm just simply going to go ahead and add them. 7 plus 5 gives me 12. That's the first part of your answer. So careful, you're not completely done. That's the first kind of part. That's the first mini problem. We're going to go through and do the same thing, but guess for what letter? Yep, we're going to do the same thing here for the letter D. So let me cover up C, cover up C here. Now take a look at what we have here. That says D to the 2nd power times D to the 8th power. Well, same thing, product of powers. We are multiplying. We have the same base, D and D. we're just simply going to add those exponents. 2 plus 8 gives us 10, d to the 10th power. That is the second part of our answer, and it just goes literally right next to c to the 12th. C to the 12th, d to the 10th power. That is your final answer. Now, do you have to actually break it apart like this? No. If you can see it and visualize, just take a look at C's, and then take a look at just the letter D's. You're more than welcome to do that. You're not necessarily have to expand it out like that. All right, for this fifth problem, this is where it gets a little weird. But what I want to do is the same thing. I want to kind of cover up and take a look at each piece at a time here. If you take a look at the very beginning here, we have that -5. This is actually what you call a coefficient. It's a number in front of a variable. That is not an exponent. So please be careful. That is not an exponent. Let me find a different color. So this -5, and let me cover up the x's so I don't work with x to the 8th. And then I have times a 6, and I'm going to cover up that x to the 3rd for a minute. Well, take a look at the problem that I have right there. That says -5, there it goes, times, oh, come on, go back. There it is. -5 times 6. Well, that's just multiplying two numbers together. What is -5 times 6? That is -30. These are just regular numbers, regular integers. -5 times 6 gives us -30. That's going to be the first part of our answer. Now let's work with the actual variables, right? Here we have x to the 8th, and if I cover up that -5, if I cover up that 6, times x to the 3rd. So what is x to the 8th times x to the 3rd? Again, I'm multiplying. I have the same base, x and x. Product of powers means that I'm going to go ahead and add those exponents. 8 plus 3 gives me 11. All right, that's the second part of our answer. -30 x to the 11th power would be the complete final answer. All right. So what you're literally doing is you're multiplying the numbers out in front, which we call your coefficients, and then you're working with those variables to add those exponents using the product of powers. All right, this last one, very similar, guys, to the one we just finished doing. So again, focus on these coefficients. You got a 2, cover up your x, don't stress about that right now, times 7, and then again, cover up that variable. Well, I literally have this problem here. 2 times 7. We're multiplying two nice whole numbers. What's 2 times 7? 2 times 7 is just 14. That first part of my answer, guys, is going to be 14. And now I have to go back through and actually work with my variables. So let me change colors here. Cover up the 2. I've already dealt with the 2. Cover up the 7. I already worked with the 7. X to the 5th times x to the, and again, this is a 1. There is a 1 there. So let's work out that problem. X to the 5th times x to the 1st. Same basis. I'm multiplying. Let me go ahead and add those exponents. 5 plus 1 gives me 6x to the 6th power. That's the second half of my answer. 14x to the 6th power would be the complete full answer. All right. So there you guys have it. This is what we call product of powers. And again, the product part, that means that you're multiplying. Notice all of these problems, there's multiplication in between. We were dealing with exponents here and there. That's why we add those exponents. Now, please be careful. There is a big difference when you are multiplying. For example, here, x to the 4th times x to the 4th. You have the same base, x and x. And I am multiplying, so I can add those exponents and write it as x to the 8th power. Please be careful. Over here, we have a plus sign. This is different. This is completely different. What you would actually have to do here is you have 1x to the 4th plus 1x to the 4th. This would give you guys 2x to the 4th power. We're not really going to see this until maybe next month, towards the end of starting next month. We'll be dealing with polynomials and that type of problem. So right now, guys, we're just focusing on multiplication. What happens when you multiply, you have the same base, you go ahead and add those exponents. So just heads up on that. All right, the other one that we learned, guys, was called power to a power. This is another property of exponents. Again, I like to think of these as shortcuts. It makes our life a lot easier. So what does this mean? Whenever you have an exponent being raised to another exponent, what you're going to do is you're actually going to multiply. You have a power raised to another power. Now here we have these letters. It's very generic. You have the base a, but you have some exponent, some number here, n, and then some other exponent, m. What happens when we have a power to a power? We simply go ahead and we multiply. we multiply those exponents. Let me give you guys again a couple of examples here. Find a different color. If I give you guys x to the fourth, and all of that in parentheses to the second power. Now notice, we have an exponent being raised to another exponent. So whenever that happens, guys, we're simply going to multiply those together. 4 times 2 gives us 8. This would be x to the 8th power. Now, it's like, why do I multiply them? Well, if you really wanted to kind of show the work, and if you wanted me to expand this, remember, this exponent means that you have 2 copies of what's inside. That means that we have x to the 4th times another x to the 4th. And if we use the product of powers, if I know if I'm ever multiplying, I have the same bases, I can add those exponents. 4 plus 4 is going to give us 8. Right? But it's nice to know this shortcut because nobody wants to go through this work. Nobody really wants to expand it out. Again, let me exaggerate it for you. Let me go through and exaggerate it and make this really ridiculous. If I give you guys in parentheses here, if I give you guys x to the, and I'm just going to put to the second power, and then all of that to, let's say, the 100th power. Nobody wants to sit here, right? This means that we have 100 copies of x to the second. Nobody's going to sit here and do this 100 times. Nobody's going to sit there and do that 100 times. That would be ridiculous. So we know that power to a power, if you ever have an exponent being raised to another exponent, simply multiply those. So what's 2 times 100? That is x to the 200th power. That is how we simplify. So there you have it, power to a power. All right, so same deal, guys. Take a minute here, take a minute, try these out. And again, like I said, these do get a little funky towards the end. But again, try it. I want to see kind of your thought process here. And then when you're ready, go ahead and hit play for those solutions. All right, so for the first one here, we have x to the 4th to the 5th power. Again, I have an exponent being raised to another exponent. What can I do? I simply just multiply it. Power to a power. Whoa, what happened there? Power to a power. We multiply. All right, so 4 times 5, sorry, going back to this problem, this should have given you guys x to the 20th power. If you got that, nice, good job. Moving on here, g to the 2nd power, and all of that in parentheses to the 3rd power. So I know that I have an exponent being raised to another exponent. The shortcut here, power to a power, says we are going to multiply. This is going to be g to the 6th power. All right. Moving on to number 3. This is where it can get a little weird, a little awkward. We have 4x to the 3rd, all of that, right? Notice the difference. There's a 4. There's a number in front of the variable, which we call a coefficient. And then, of course, you have x to the 3rd, all of that in parentheses to the 2nd power. Okay, so again, remember, what does that 2 mean? That 2 means that we have 2 copies of everything that's inside. So if I actually break this apart, you have 4x to the 3rd times another 4x to the 3rd. Okay, if you actually multiply that out using a product of powers, right, for multiplying here, what is 4 times 4? 4 times 4 gives you 16. And then what is x to the 3rd times x to the 3rd? Remember, if you're ever multiplying and you have the same bases, you just add those. So what is 3 plus 3? That gives me 6. This would be 16x to the 6th power. There's a different way you could have approached this. The other way you could have approached this is thinking about multiplying just like we did before. So let me kind of try to break this apart here. So let me show you guys a different way to get the answer. And it's up to you which way you prefer. We realize that we have 2 and a 3. So we are going to multiply those. And we would actually also have to multiply not the 4, but there's something right here. There is an exponent, but we don't write it because it looks tacky. There's actually a 1. So what we can do is we can actually multiply that 2 into all of these exponents. So what is 2 times 1? 2 times 1 is 2, so I would rewrite this as 4 to the 2nd power. Let's multiply again. What's 3 times the 2 here? That gives us 6. This would be x to the 6th power. And notice, little by little, it starts to turn into that answer that we had before. What is 4 to the 2nd power? That means 4 times 4. What is 4 times 4? 4 times 4 is 16. 16x to the 6. So notice, guys, there's more than one way to kind of approach this problem or kind of think about it. It's completely up to you. Okay, so let me move on to the fourth one here. If I go ahead and I'll do it the longer way here, this means that we have how many copies? We have 3 copies of everything that is inside. So let me actually expand this out. 2x to the 8th times 2x to the 8th times 2x to the 8th. Now notice sometimes it's a little bit easier to use the other way. Especially if that 3 was a much larger number. So what can we do next? What can we actually do next to simplify this? Well, what's 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. This would give us 8. Now let's do the same thing here, but we're going to do it with the x's. Now be careful here. We have x to the 8th times x to the 8th times x to the 8th. Remember, careful when you're dealing with exponents, and if you're ever multiplying and we have those same bases, x, we are going to go ahead and add those exponents. What's 8 plus 8 plus 8? That is going to give us 24x to the 24th power. That is your final answer. And again, if you wanted to do it kind of the other way here, what you would have done is you would have multiplied 3 times the 8 here, and you would have also multiplied 3 times the 1 that we technically do not see there. All right. So you would end up with 2 to the 3rd power and then x to the 24th. But we can do better than this. What's 2 to the 3rd power? 2 times 2 times 2 3 times. That would be 8. 8x to the 24th. So there you guys have it. You have options. It's completely up to you how you want to get to that final answer. All right. For the bottom ones down here, it looks like we have fractions. So don't get overwhelmed. Again, take a look at this piece by piece. I would ignore the denominator for a minute. Imagine that was never there. Doesn't this look exactly like problem number 1? Except I have an n instead of an x, right? But it's the exact same problem. What do we do when we have a power to a power? We go ahead and we multiply those. So we would get n to the 20th power up above in our numerator. Now I want to do the same thing, but this time, I'm going to cover up that numerator, and I'm going to work with that denominator. We have m to the 8th power being raised to the 5th power. We're still multiplying those exponents. Power to a power, we multiply. 8 times 5 gives us 40. M to the 40th power, that would be it. That is our final answer there. All right. The last one here, guys. What I'm going to do here, again, cover up that denominator. Here, be careful. This 5 is your base. That is not an exponent. That is not an exponent. That is not an exponent. So what you want to kind of think about this here is you have 5 to the 2nd power. You have 5 to the 2nd power. Well, what does that mean? That means 5 times 5. Well, what's 5 times 5? 25. This numerator turns into 25. Now we're going to do the same thing with the denominator. Now be careful here because this 6 is an actual exponent, right? And if we're dealing with exponents, exponent times an exponent, a power to a power, excuse me, we're going to multiply those. X to the 6th to the 2nd power, 6 times 2 is 12. And there we have it, that final answer. All right, guys, so here is your class activity. Again, make sure you guys do this on a completely separate piece of paper. Please don't attach it to your notes. The notes, you should be holding on to those. So separate piece of paper. Make sure when you guys are finished, check your answer with my sub. They should have the answer key. And then if everything's perfect, go ahead and make sure your name's on it. Turn that into the inbox for me, please. All right, guys. Take care. Enjoy the rest of your day.